So thank you all for coming. My name's Adrian Justice, and today I'm going to be showing you how we can do some interesting stuff with our, production-grade web servers. We'll do everything from detecting the sort of activity that nation states are using against web servers today, through to destroying them if we really want to. We don't need too much about me. If you're interested in this IIS sort of stuff, I've been starting to put more of it up on Twitter, so feel free to give it a follow. Otherwise, let's get into it. And we'll start off with probably the most obvious question for everyone in the room. Why in Christ's name would you inject game mods into a web server? So believe it or not, I actually came up with the idea whilst trying to solve a legitimate problem. How do you gain visibility of adversaries abusing legitimate .NET functionality? Now, through my day-to-day job and in my personal research, I deal with a lot of post-exploitation activity on IIS servers. And while some of the crappier stuff that I deal with looks a little like this, that's really small, but it's basically cmd/c, let's run a thing. Hunting for this stuff is, did something spawn out of W3WP? That's IIS if you've never seen that before. If your EDR doesn't show you that, you've either haven't set it up right or it's time to get a new EDR. This is the most basic of IIS exploitation. Not everything's this easy, though. For example, what would you do if you came across this on your web server? If you decided to sort of deobfuscate that, I'm telling you, you'll make it to another eval function that just evaluates a post parameter, so not the most useful thing for analyzing the file. You might be thinking, I'll just go and look at my IIS log files. That's a good starting point. That's what you'll see. You've got some IP addresses in there. Maybe it's the adversaries. Maybe it's that load balancer you never got around to setting up log forwarding for. And you've got some user agents, but they tend to randomize for every single request. So nothing overly useful there besides timestamps. For all you know, the adversary ran a directory listing 10 times, or they exfiltrated half your domain. You've just got no idea through this. Ideally, to analyze a web shell like this, or to see the capability that this adversary has, we need to get some form of visibility of the eval function that's wrapping all of that disgusting code. Now, monitoring functions is by no means a new concept. If you've ever looked into how AV or EDR works, you've probably come across the concept of function hooking. It's been mentioned in a few of the other talks today as well. The general idea, if you've never seen it before, is to hook a function, you overwrite the first instruction of that function with an unconditional jump out to some code you control. Once you're in that code, you've got access to the stack and the registers that contain the state that was sent to the function being called, and you can now do whatever you want with it. You can write it to a log file, fire off an alert in your EDR, tamper with the parameters, do anything. Importantly, if you don't want to break things, you need to re-implement whatever instruction you overwrote with your jump, and then unconditionally jump back to just after your hook point. If you do everything right, then the person calling your hooked function has no idea that it's hooked, and you get your additional visibility. Great, so function hooking's a thing. Just do that. Why are we screwing around with game mods? Well, unfortunately, everything we just went through only applies to unmanaged or native code. Think everything in the left-hand column. So C, C++, Rust, Golang, anything that compiles down to native assembly code that your CPU can execute. When it comes to IIS, we're dealing with things like C#, VBScript, and JScript. These sit in the managed language category, which is in the middle. These languages compile down to an intermediate language code, so it's kind of like assembly, but it's not for your CPU. It's for an intermediate language sort of interpreter. In C# in the .NET world, this is the Common Language Runtime. If you're familiar more with the Java side of things, the kind of equivalent would be the Java virtual machine over there. Now, I assumed that I probably wasn't the first person to ever want to gain visibility of a managed function, and I started thinking what other problems could be solved with this, or who's probably already done this work to do the heavy lifting. And straight away I thought of game mods. This is basically all they do. Like, a game mod wants to manipulate the functionality of a game to change how a certain aspect of it runs. And logically, the only way of doing that is to have some way of hooking a function. Now, I was interested in .NET, and one of the more popular, up until a week or two ago, development frameworks for games was Unity. They kind of pissed off a lot of people recently, but whatever. There's a lot of games out there that are written in Unity, and quite a few of them do have some level of unofficial aftermarket support for mods. So I figured that was a good starting point. Looking at the list of popular games with mods, I recognized one on the list, RimWorld. RimWorld, if you've never seen it before, people have done some crazy shit in this game with mods. The regular game is sort of a ground-based colony simulator sort of thing. People have turned it into full-on space warfare and all sorts of other stuff. Doing that sort of thing requires hundreds of mods from hundreds of developers all running in the same process, most of the time not crashing. So I figured whatever could do that could probably handle me poking a few web shells. Doing a bit of research, I found that most of these mods are built on a framework known as Harmony. Harmony was actually originally developed as a RimWorld modding framework. It's since been, I guess, genericified down to support more generic .NET games and just .NET-based applications as a whole. So it allows you to gain that function level visibility that I was after. So perfect. Now, before we get into actual game mods, I wanted to cover off on just a little bit of terminology so we're all on the same page when I mention it later. First one, .NET. So you should probably know that one to start. .NET is not a language. .NET is a platform, whatever that means. That's Microsoft's description of it. There's multiple languages that will build build code that supports .NET or is .NET. Main ones you're ever going to deal with is C# for most modern web applications that are built on the .NET framework, or the more recent, just .NET. That sort of covers everything from your Windows form-based application through to something running on an IIS server. Visual Basic, not super popular these days. Most people just know it as the macro language that screws their network over more often than not. And JavaScript.NET is more or less dead except for shitty web shells like the one we saw at the start and the ones that we're going to see later on. .NET Assembly, we don't need too much about this today. A .NET Assembly has a lot in it, but for today's purposes, it's a DLL or an exe that you get when you build a .NET application. The big string over to the right of that is the way we reference .NET assemblies. So the first part is the simple name of the assembly. We've got a version string. Adversaries are really bad at remembering to set the version string for some reason, and so often they just set it to all zeros. So if you're ever hunting for this stuff and you see that, might be worth paying attention to that particular file. Culture should pretty much always be set to neutral unless you're dealing with a resource or a system assembly, which is pretty rare. And public token is used when signing assemblies, but nothing really validates or enforces the signing, so not a whole lot of people actually do it. Reflection is by no means a .NET exclusive concept. Plenty of languages have it. General idea of reflection is through a bit of black magic, an application can inspect its own running process and determine information about its own types, methods, things like that. It's also capable of dynamically invoking them, and just to be a pain in the ass on .NET, it's able to load entire .NET assemblies from byte arrays that come from mysterious buffers that are populated over an internet connection. It's not a bug, it's a feature. No, you can't turn it off. Adversaries love this shit. All right, let's actually get into some hooking. I'm going to be interchangeably using hooking, patching, modding all throughout this, so it's all more or less the same to me. We're going to avoid IIS to start with. It just adds a little bit too much complexity that we really don't need to deal with. Instead, we're going to write our own basic .NET application. We'll develop some mods for that, and then we'll take things from there. So here's our basic app. Just has a log function. If you pass a string to it, prints it out. If we give it a run, it does exactly what you'd expect. So before we can write mods for this, we actually need to get Harmony installed. I'm going to be doing all of this through Visual Studio. If you do anything else, you're on your own. So once we've got our project created, right-click on our references, choose Manage NuGet Packages, search for Harmony, and we're after libharmony 2.2.2. Hit install, and you've now got Harmony installed, and you're ready to start modding. All right, so the screen may look a little dense and a little complex in some areas, but it contains basically all the information that we need to write most of the mods that we're going to be doing today. So to get started with Harmony, we import it. That's cut off at the top, but I'm sure you can work that one out. We then need to create a new instance of Harmony, passing in some form of unique string identifier. For the game modding sort of side of things, this tends to be used as a way of identifying your instance of Harmony, but since we're shoving this into a web server, probably not a big issue. We've got bigger problems if we run into another instance of Harmony on our web server. After that, we need to call patch all on our object. Patch all will use some of that reflection black magic to analyze our currently running assembly and identify any classes that are tagged with this harmony patch attribute down the bottom. We don't need to worry too much about what attributes are in C#. Just think of it as a way of tagging the class that is underneath it. I've got 3 separate versions of harmony patch here. You only ever need one of these. I'm just showing a few variants of this. So the first column of the harmony patch is the type that contains the function that we're going to hook or write a mod for. In this case, we're going to be targeting the log function above the red box, and that is part of the program type, which is defined right at the top. So we use type of program. Later on, when we're targeting actual functions in the .NET framework, you'll see much longer type definitions here. Next up, we need to define the name of the function that we're targeting. So that is log in this case. We can either specify it as a string, or we can use the name of function down the bottom to dynamically resolve it. Harmony recommend, or the Harmony docs recommend the bottom option. I have no idea why. It's a massive pain in the ass if you start trying to target private functions that you're not really supposed to tamper with, but you're also not meant to mod things like this. So yeah, I don't know why they went that approach. I'm going to be using these two interchangeably, but for most of the time, you should probably just stick with the string version at the top. Yes. Last but not least, we have an array of types. So C# by default supports function overloading. General idea of that is we could have 5 different functions all called the same thing, but with different parameters. So for our log function, we might have a log function that takes a string, one takes an int and a string. As the developer, you just write log and pass stuff in, and it just magically works. But for us, we don't quite have that convenience. We need to explicitly determine which function we want to hook. So we do that by passing in an array of types that match the target function. So in this case, target function takes a single string, so we pass an array of types that contains a single string. Next up, we've got our hook class. The name of this class can be whatever you want. I recommend going for something that sort of is descriptive of what you're actually trying to achieve. Within that, there's several different functions we can selectively create depending on what we want to achieve. So a prefix function will run before the target function, so in this case, before the log function. And it's typically used if you want to do something with parameters. So you want a log parameters being passed in, you want to tamper with them, or you want to straight up prevent the target function from running. The parameters for this function need to match the target function. So you'll see we've got a string called message in both of them. The type and the name have to match. So if you make the prefix function have a string called MSG, it's not going to compile properly. Next up, we have a postfix function. These run after the target function. So you can no longer affect the execution of a function once you're in the postfix. The target function has already run. We typically use these if we want to get access to or modify the return value of a function. Postfix functions have a special variable defined by Harmony called _result that has the type of the return type of the function you're targeting. So in this case, the log function returns an int, so our _result value needs to be an int. Later on, we'll see some that return a string array. In that case, _result will be a string array. With this mod set up the way it is, if we were to call the log function, this is roughly how it would go. So our prefix function would be called first, then the actual log function, and finally the postfix function. All right, let's actually write our first mod. So we've got a sample application here. It just calls log a couple of times, and we're going to write a couple of hooks for it. So first up, we have just a generic log printing out welcome to my first C# application. This is happening before any hooks have been enabled, so we would expect this to log in all of our applications without any issues. Next up, we create our instance of Harmony and we call patch all, so now our hooks are active, our mods are active, and we're good to go. We call log again. This one is now subject to our hooks, so whatever we do in our mod down the bottom, we expect it to affect this function call. So our current hook this time is a single prefix function, so we're running before the target function. We're interested in parameters in this case. We've got the message parameter being passed through, and we're just going to wrap it up in our own string and write it to the console. Importantly, we explicitly call console.writeLine here. We don't use our log function, because if we call the hooked function from within the hook, we're going to have a bad time. So if we give this a run, we'll see that our first log function runs unaltered. Our second call has successfully been hooked, so we've had a function run before the actual log function, and then our log function has been allowed to run. This may seem like an incredibly boring mod. It's actually the most useful one for the sort of stuff we're trying to do, so trying to improve visibility of web shells. We used a log function here. What if we just made that eval function from earlier on? All of a sudden, the code that's being passed in to be evaluated can be written out to the console instead. So we'll be using this type of mod quite a few times throughout this presentation. Next up, what if we wanted to manipulate parameters to a function? Well, all we need to do that is add a ref keyword to the parameter being passed in. Once we've done that, we can just replace the contents of the parameter, give it a run. Our second log function has now been replaced, so we've changed that parameter. So C# by default is a pass by value language. So if you pass a string into a function and you make all of the characters in that string uppercase, you're changing a local version of that string local to your function. You're not manipulating the original parameter that was passed in. If we set the ref keyword, we change it to a pass by reference call. So now the original value that's passed in, any changes that are made to that, we're changing the actual value that will be used later on in the application. So by doing it this way, we're manipulating the parameter that will be ultimately passed on to the actual log call. Next up, what if we want to just prevent the function from running altogether? So we've been doing a log function now, up until now. If an admin came along and checked their logs and all of a sudden every single log has been replaced with this static string, that looks pretty sus. It's better if we just don't log anything anymore. To do that, we just change our return type from a void to a Boolean and return false. If we give this a run, we'll see that that second log message is no longer running. So we're kind of abusing a feature of Harmony here where I believe it's used if you want to just replace the functionality of a target function. So if you think from a game development sense, if you wanted to replace, say, the render function with a custom one that makes everything black and white, you write a prefix hook, you do all the logic to spit everything out in black and white. There's not much point then calling the original function and have it just be rendered in color over the top. So if we return false, it prevents that original function from running. We can abuse this quite a bit throughout this presentation to just straight up disable functions that adversaries like to use. All right, we've got one more sample application, and then we'll actually get into some IIS stuff. So our second application here, we've got a function that returns an array of strings, and then just iterates over them, printing them out. If we give it a run, we'll see there's an interesting user in the middle that probably doesn't want to be showing up in this log, so we're going to help filter them out. So because we're interested in running stuff on the results of a function, we now need a postfix hook, so this will go after. We've got a ref keyworded string array _result parameter. So _result, because that's Harmony's magic value that'll be populated with the return value of the target function, in this case, the array of users. We've got a string array because that's the return value or the return type of the target function, and ref keyword because we want to actually be able to manipulate it. If we just wanted to log these parameters, we wouldn't need that ref keyword. All we're doing then is completely replacing the array with a new array that contains all users except for good old totes legit. If we give this a run, we've now completely filtered that user out, so we've tampered with the output of this function. Plenty of ways that this can be very useful, especially if you're going to be a dick and filter yourself out of logs. You didn't learn it from me. All right, I think it's been about 20 minutes. I think it's time we actually get into some IIS stuff. For this section of the presentation, we're working under the assumption that we're on the blue team. Like, we own the server legitimately, not we own the server, and we can do whatever we want. We're going to be going with the more official way of extending IIS's capability, which is known as IIS modules. We're going to be using an IIS module to essentially bootstrap our mods into Harmony. So if you've never heard of IIS modules, we'll take a look at where they are. This is the IIS user interface, if you've never seen it before. If we click the really small button that's in slight blue in the middle, we'll be able to see the list of modules that come with IIS. These do everything in the guts of IIS, from like handling authentication to session management, logging, all that sort of stuff. So we're going to make our own one of these, slot it into IIS, and that'll be how we get our code running. So to write an IIS module is dead easy, especially when we're not using like 99.9% of the capability of these things. We're just going to use it to load Harmony. So that really small code up there that's probably damn near impossible to read is our IIS module. I'll read to you though, so you're fine. So to make an IIS module, we need to make a C# class, or a C# library application, not a console application. So we want a DLL, not an exe. We need to make our class implement the iHTTP module interface. To do that, we need to have a init and a dispose function. The init function gets called anytime a new version of W3WP is created, so a new instance of IIS's request processor. Dispose is called whenever one of those is destroyed, but we're not doing anything in dispose, so it's fine. In our init function, every time a version of IIS is created, we need to create a new instance of Harmony and call patch_all. That will go through and load any of the mods that we've created later in the presentation. All of those will be just appended to this file down the bottom as just more and more classes. So I won't be showing this again later on, but any of the mods that we develop from here on out, just assume they go into this file. The only other thing of note in this file is we've got a log function that writes messages out to a text file. It's a pain in the ass to attach Visual Studio to IIS to get debug messages out. So this is just a convenient way of seeing the output of our mods. Now that we've got our IIS module complete, we compile it. That'll give us a .NET assembly or a DLL. We need to copy that to the bin directory of our web server or our web root. On a default install of IIS, that is C inetpub www root bin. The bin directory doesn't exist by default, just make it, it'll be fine. Now IIS isn't stupid, it's not going to just randomly execute a DLL you drop in a magic directory. We need to register our module. We do that through that screen that we saw previous slide that listed all of our modules. We click Add Managed Module in the top right, give our module a name, can be anything you want. We need to specify the type of our module. So the type is our namespace in the top left, dot our class name. Hit OK, you'll get a warning that it can't find your module. That's fine, it's looking where system assemblies exist, not in the bin directory. It'll work later, don't worry. So to test out our module, just open up a web browser, browse to any old ASPX page hosted on our site, and we should see a message pop up in our log file saying that our mod has loaded. So we're good to go, we've bootstrapped Harmony, we're ready to start writing some mods. Before we do that though, we should probably work out what we actually want to achieve. The .NET framework is freaking huge, like millions of potential functions that we could target, so it helps to have a general idea of what we want to achieve. Now, for today's presentation, I'm going to give us the goal of working out what the web shell we saw earlier does. So this web shell is Antsword. It's available on GitHub, open source, mostly in English. You might need a little bit of Google Translate to help with some Chinese, but it's fine. So we'll work out what the adversary is actually doing when they call this shell. So for starters, we need to work out what functions we're interested in here. We got the obvious one at the start. Eval would be nice to see. But there's a few others in here we could potentially target. GetString is a possibility. I'm going to go with from base64 string instead. Main reason here is adversaries love to base64 encode everything. If we go with getString, we'll get all the strings. That's fine. If we go for from base64, we'll get all the strings, any .NET assemblies they send, any encrypted blobs, configs, files, all sorts of weird and wonderful crap that they'll send us. So it's a much nicer one to go for. Now, I don't know about you, but if you've ever done any .NET programming, eval is not actually a function. It's kind of a function that exists in the JScript side of things that gets mapped to something else at compilation time. So we'll have to do a little bit of extra work to work out what we're targeting there. The adversary has given us the full class path and everything for the from base64 string though, so we're good to go and start hooking that one. So in order to work out what the eval function is, we'd have a few options. None of them I can do in this presentation because quite frankly they will take too long. The way I originally worked this out was compile that shell and then put it on an IIS server, access it, decompile the version that IIS builds, and take a look at the decompiled source. That'll be done post-translation of this JScript code to .NET and allows us to go and see what that function will have been turned into. In this case, it's turned into Microsoft.jscript.eval, and it's this JScript evaluate function. Other ways you could do this is try and write code, like for other functions that you're trying to work out, write code that uses the target function and use a bit of a debugger to see what ends up in it. Read documentation, Google's your friend sometimes. God help you, ChatGPT might do something. So we've got a function here that we can write a mod for now if we're interested in it. But you'll notice there's actually two different functions called JScript evaluate. They have slightly different parameters in them. We could just write two different mods here and hook both of these functions, but that's extra effort. If we look towards the end of both of them, they actually both call this do evaluate function. So if we just hook that instead, there's only one version of that, so we get away with a single mod. So we've now got our two target functions that we're going to write some mods for. So let's actually write these. We'll start off with the do evaluate function. So we've got a type of microsoft.jscript.eval and a function of do evaluate. The type array is actually truncated on the slides, but we don't actually need it in this case because there only is one do evaluate function. Within that, we've got a source parameter that we're just going to log out to the console. So very similar to that very first mod that we wrote. How do we know it's the source parameter? We got docs. So we've got documentation for the original JScript evaluate function, which ultimately called this do evaluate function. So logically, the source parameter that you definitely cannot read on there, but it says the code to evaluate, probably the parameter that we're interested in. The other option is, again, debugger, step through this thing and see what ends up in these parameters. Or there's only 3 of them, just log them all, see what happens. The next mod that we're going to do is our from base64 string function. And this one looks a little bit more complex than any of the previous mods we've done. We've got both a prefix and a postfix function here. So the main reason for that is I want to log both the input and the output of this function. Because if an adversary sends, say, a .NET assembly, base64 encoded, we decode that, we convert it to a string and write it to the console, pretty good odds our log message is going to say mz null. And we've lost all of that useful information. Whereas if we log the input as well, we get mz null and 100 kilobytes of base64 encoded data we can go and look at in other things. Now, there's no way in Harmony itself to get both the input and the output at the same time. The way we can work around this is with something that Harmony calls state. So _state is a special parameter that you can supply in Harmony. The type can be whatever you want as long as it's the same between both your prefix and your postfix function. And anything you assign to this _state parameter in your prefix function will be available to you in your postfix function. So in this case, we assign the parameter s. Remember, we don't control the names of these parameters. That's the name that Microsoft uses for the actual parameter in from base64 string. So we're assigning the input string to that _state value. This allows us to then log both the input and the output to the console. All right, let's see our mods in action. We recompile everything. We recopy that DLL over to the bin directory. We don't need to re-register things with IIS or anything. All of that's taken care of for good now. So all we need to do is get our adversary to attack us again. So we'll go over to Antsword and we'll run our command again. Also too small, but that's who am I. And they are running as NT authority system. So adversary's having a good day here. So you can see how little output showed up on the adversary screen. Let's see how much we got with our logging. Holy shit, that's a lot. All right, we'll go through it line by line and work out what we've actually got here. So I'll put the web shell back up there so we can start to see where some of this data may have come from. And right away, it's looking pretty promising. Our first call to from base64 string has an input parameter of UA. In the highlighted blue box on the screenshot, we can see there is a call to from base64 string with a parameter of UA. We got another one with MQ, so it looks like our base64 hook is working. The output parameters are boring as hell, but whatever. Next up, we've got this giant base64 encoded string. It's not immediately obvious where that comes from, but if we look at the box up the top, we can see bits of it dotted all throughout it. So it seems like everything between the eval brackets of the whole web shell ultimately is just to construct and then decode this base64 encoded string. If we see down the bottom, that's the output of that string. That is the furthest point you could have gotten if you were to statically analyze this. So if you were to manually deobfuscate that web shell, that block of JScript down the bottom is the furthest you could get. We can go through that JScript and work out roughly what we've got so far. So we've got two numbers. AntSort uses these as like a bit of a delimiter sort of thing. So if you pass a number to the eval function, it outputs the same number. So if you put one of those at the start and the end, then you've now got two known numbers you can look for in the response data coming back and just pull out everything in between, and pretty good odds that's the output of your function you're interested in. Other than that, we've got yet another call to eval, this time wrapping a post parameter called ant. So we've already made it way further than our original IIS logs got us or anything like that. Moving to the next section, we've got our first call to JS eval. And surprise, surprise, the contents that we just base64 decoded are passed to eval. So ultimately, this call is the equivalent of the entire web shell executing. Straight after that, we've got yet another call to JS eval. This time, it's the equivalent of whatever is inside that ant parameter. So this is information that we have not been able to see so far. This is only available because we wrote this hook. And we'll see that this is yet another call to eval with even more base64 encoded data with another post parameter. I'm not going to go through any more of these. It does this 4 or 5 times, just slowly pulling out more and more stuff. We'll just jump straight to the final call to eval, which has something actually interesting in it. So here we've got the final payload that was sent to our web server. And we can see right at the start, we're starting off much stronger. System.diagnostic.process_start_info. So we're creating a process here. We've got quite a few request items here, so more post parameters. Unfortunately, we didn't have anything we hooked to get visibility of post parameters, but adversaries love to base64 encode everything, so we got them through that. So we can see that they ran cmd/c, who am I? So we've been able to fully reconstruct the actual command that the adversary sent to us. I will acknowledge that I was shitting on the subprocess-based shell at the start, and now I used one as my demo. AntSort does far more stuff than this and would be able to pick up all of it. It's just, this is a nice demo to do. What did our lovely IIS logs get during all of this? Someone ran a post command. Nice. So I'd say we've successfully improved our visibility quite a bit. But if we go back to that last image, there's something quite interesting towards the end. Response.write. That sounds like something we could have some fun with. So again, response.write in JavaScript is not actually response.write in .NET. It's HTTP response.write. So we can rig up a basic module that just logs all calls to HTTP response.write. Do not do this on a production server. You will have a very bad time. But on our, especially not a Exchange server. But on our test server that is only us and the adversary using it, we're all good here. So we're just going to write out the contents of whatever the adversary is attempting to send back. If we rerun our attack, we can see that we get back the output that the adversary is getting sent. And we've actually analyzed enough of AntSort now to know exactly what all this is. We've got the numbers either side. Screenshots were taken at different times, that's why they don't line up, but that's the numbers. We've got the output of their command. Who am I? NT authority system. Some random number, CD, some random number. So the random numbers are the same thing again. They're a delimiter that's been put in. This time they have to use echo because they're running it in sort of the context of CMD, not that eval command. But it's ultimately to delimit the output of CD. On Windows, CD doesn't change directory if you don't pass any parameters like it does on Linux. It just prints out the current directory. So we can see their parameters. Surely we can tamper with them. I'm going super ghetto here. I'm just doing a full-on string replace on the output of NT authority system. If you were wanting to do this in a production environment, I don't know what a production environment for modding an active web shell looks like, but if you wanted to do that, you'd probably want to try and extract those magic numbers either side so you had a bit more of a strong way of doing this rather than a ghetto find and replace, please always run who am I and nothing else. But we can see what this actually shows up as in their UI. They run who am I, who are any of us. Sweet, we've successfully changed the output that goes back to the adversary. That started to get me thinking though. That's a good looking terminal. There's colors and shit in that. Like, surely we can do more than just some boring line of text. So here we've got AntSort, the adversaries connecting to our web shell, and then nicely zooming in the screen so that we can see them. I've made a new version of this mod. So when they run who am I, we get some multi-line text. That's just formatting complete, but it's a bit small. We can do something a little more interesting than just text, though. I tried a bit of cross-site scripting in here because this is just an Electron app. They have actually filtered that out. I suck at cross-site scripting, though, so who knows? Maybe somebody else could do it. I can do colorful squares, though. And if we've started to, have some fun with our adversary friend, and maybe you're starting to suspect who they potentially could be, who the boss is. So we've had some fun with our adversary, but I think it's time we break up with them. And we're going to be a massive dick, and we're just going to ghost them. So we'll write one last mod. We're going back to our doEvaluate function. But this time, we've changed the return type to bool, and we're returning false. Adversary can keep lobbing payloads as much as they want at us now, but eval is no longer allowed to execute. From their end, they've been completely ghosted. They're getting absolutely no output again. So eval shells will never work on this host again unless the adversary can somehow get their own mods on there to unhook our hook. So that's more or less it on the defensive side of things. JS eval shells, again, broken forever, but that's only a small percentage of what adversaries use these days. I've got 3 other things up here that are way too small, so I'm not going to go through them in great detail. But we've got sub-process-based shells, reflectively loaded .NET assemblies, and Microsoft got rid of eval in C#, and they decided the great replacement would be dynamic compilation of C# source code. The bottom shell will get rid of that. Adversaries do all of these things quite regularly. Yeah, if you could run all of these on a production web server, you would probably stop 99% of web shell-based compromises. But they're too small, so we'll skip through them. If you're interested in this stuff, chase me up afterwards, and I'm happy to show you these ones. All right, so let's get into the offensive side of things. On the offensive side, we can do some interesting stuff, like intercept information that other people send to web servers. So when we do stuff from a web shell, usually anything that we run is running in the context of us. As the attacker, we've logged into an Exchange server or something, but it's still happening as far as like our authenticated session. Through a mod, we're sort of running stuff as part of whoever calls that function. So that gives us some interesting opportunities. Other than that, we can yeah. It's not to say that we can't do a lot of stuff on the offensive side. It's more that by the time you can deploy one of these mods, you've got far better ways that you could do just about anything. You need a web shell to get all this stuff loaded. Do your sub-processing, do your persistence, do your file exfiltration, do all of it through the web shell. Don't fuck around with mods. It's just not worth it for this. So for once, we have something that's nicer for the blue team than the red team. So for my offensive demonstration, I'm going to avoid doing a IIS module again, just so I can show you another way that we can get Harmony up and running. So we're going to use game mods to develop a Microsoft Exchange OWA credential logger in the form of a web shell. Now, web shell code, we'll start by writing the web shell, then we'll get into the mod itself. So this is our basic web shell. We don't need to know too much about this stuff. To write a web shell, you implement iHTTP handler, make a process request function. Process request function will run anytime a request comes to your file. So like mywebshell.aspx will cause that function to run. Our particular one, we just pull out a parameter called mode, like a get parameter. If you set it to hook, we'll run our hook code, which we're going to write on the next slide. Our hook code will set up a hook that every time a user authenticates, their credentials are captured and written to the creds array up the top. If you run the list mode, we'll iterate over that creds array and print out all of the credentials that we've logged. And if we run clear, we'll clear them out so that nobody else can see them. So we'll go to our hook code. I will say now, this is written, like this is heavily using .NET Reflection to dynamically locate and call stuff. The only thing shitter than talking through code is talking through reflection code. Like, this stuff is horrible. If you've never seen it before, I am sorry. Take a photo and Google some of these functions because I don't have time to explain a lot of how this stuff works. As for why this looks more complex, though, it all comes down to this first section. So normally when we've started Harmony, the very first thing we have to do is install it through NuGet and then import it. We can't do that with a web shell. A web shell is more or less a blob of text that we tricked a server into writing to disk and then executing. When that happens, we can't control the environment that this is going to be running in. So we can't say, by the way, we need this game mod loaded into Exchange so we can access all these types. We need to bring all of that stuff with us. That's what the red box on the left does. So the very top line, that's a truncated base64 string, that is a 1 megabyte base64 encoded copy of harmony.dll. So we're decoding that into a byte array. If we had our previous mod installed on this server that logs from base64 string, we would see this. Remember, adversaries love to use base64. We are the adversary now. We've then got a call to assembly.load, which takes that decoded .NET assembly and loads it into memory. Adversaries love using assembly.load. Yeah, it's great fun. So now that we've got our assembly in memory, we're ready to start moving on with our hook. So to get this hook up and running, we need to find two key functions. The first one is the target function that we want to hook. So this will be the equivalent of our log function or our eval function, that sort of thing. In this case, it's the handle FBA auth form post function under the Microsoft.exchange.http proxy.fba module type or class. I didn't name this shit, Microsoft did. I found this stuff by just randomly reverse engineering parts of Exchange till something said password. The other function we need to get access to or get a reference to is our postfix or our prefix function. So the function we want to have run anytime somebody attempts to authenticate to our target server. So we'll find the first function first. To do that, there's no real better way than straight up brute force. So we iterate over all the assemblies currently loaded into our process. For each assembly, we then say, hey, do you have the type we care about? If it says no, then we move on to the next assembly. If it says yes, we say, sweet, give me a copy of, or give me a reference to the function that I'm interested in. Once we've got a reference to that function, we're good to go on that path. The equivalent of doing this on our more C#, like we can import Harmony and use everything sort of thing, is this. Access tools.method passing in the thing that we're interested in. This is just a convenience function that Harmony provides to us that basically does everything on the left but behind the scenes. When you start doing this stuff manually, a lot of it's pretty disgusting everywhere. We can't use the nice patch-alls or anything anymore because we're targeting functions, or we're targeting assemblies that exist in other processes that we can't really build against. Next up, we need to get a reference to our prefix function. Now, we're not constrained to calling it prefix anymore. We can name it whatever we want. So I've named it onExchange login. So this function will be executed whenever somebody authenticates to this server. Thankfully, because this belongs to us, it's part of our type. In this case, our type is myloader. We can just use type of myloader.getMethod on Exchange login. So we've now got a reference to both the target function and our prefix function. Now, the equivalent of doing this on the regular old C# application side is actually exactly the same. When you start dealing with reflection, there's not really a nice way around it. Now, Harmony expects our prefix function to be wrapped up in a nice class called Harmony method. So we need to get a reference to a Harmony or the Harmony method type and call the constructor of that, passing in the parameters that it's interested in. This looks something like the bottom right, where it's new Harmony method prefix. So we're just locating the target type, calling the constructor of it, and passing in a reference to our prefix function. Almost there. We now need to finally create an instance of Harmony itself. So this is exactly what we've done several times before. Same general idea, we find a reference to the Harmony type, and then just call the constructor of it, passing in our identification string. Last but not least, we call patch on our Harmony function, passing in a reference to the target function and our wrapped up prefix function. So if all of that works, we should be good to go. One last blob of code, and then we're ready for some videos, and we're almost done. This looks like a lot. We actually don't need, we don't need all of that bit in the middle. That was directly lifted out of the target function that we're hooking. It just determines whether this is actually an authentication request or not. So we don't need to worry about that. What we care about is whenever our function runs, we acquire a reference to the form being passed in. We copy out the username, password, and password text fields. No idea what password text is. I just saw it there and logged it. I've never seen it populated, though. We mash all those together into a string, and we add it to our creds array for later retrieval. So let's see this in action. On the left-hand side, we've got our unsuspecting user that's going to log into their email account. And on the right side, we have our attacker workstation. So the attacker runs the hook command, so that will initiate the hook. User comes and logs into their email account. They're successful, good on them. Attacker comes back and runs the list command. And we've got the clear text credentials of the administrator that just logged into their account. If we give it a second, though, and then refresh our log, we get something interesting. I wasn't expecting this when I started writing these demos, but it seems like there's some automated authentication that goes on in the background of Exchange. So these are health mailbox accounts. You can't log in with those creds or anything. No idea what they're for. Put crap all effort into looking into these. But if you know, let me know. So that was more or less the end of the presentation until I realized I made a bit of a promise in the title and haven't really lived up to it. I said we were going to nuke a server, and we haven't done that yet. So let's burn an IIS server to the ground. So we're going to go back and replace our cred logging function with a nuke function. When somebody logs into their account, passing in a username that is anything other than one of those health mailbox accounts. We don't want to do this when an automated authentication occurs. We want it to be a real person that sees this. When that happens, we're going to acquire a reference to physical disk 0, so this is your hard drive, and we're just going to write some zeros over the first 512-ish bytes, which contains the master boot record. If you don't know what that is, it's the thing that tells you you have partitions. And if you don't have partitions, you don't have a computer. After that, we shell out to PowerShell to restart the machine, because even though we're running a system and we have permission to erase the MBR, we don't have permission to shut the computer down. Turns out the system user doesn't have that privilege. There's ways to give it to yourself, but it's far easier to shell out as administrator that does have that permission. So one more demo, and then we're good to go. So on the left, we've got our actual Exchange server. Top right, we've got our attacker workstation. Bottom right, we've got our unsuspecting user just trying to check their emails. So we run the nuke function. This is implemented in the same way as our hooks from our previous slide. Nuke is armed. Someone comes and logs into their account. Bye-bye server. Tries to shut down and tries to fire up again like all good servers should. It seems there's no partition tables left. So game mods can give us amazing visibility of stuff. We can see things that you would never be able to see even through full packet capture. They're not just for party tricks like nuking servers. Do not nuke somebody's server, and if you do, do not blame me. I do recommend giving this a go, though. It's a lot of fun. You'll notice a lot of the mods that we demonstrated today were, one line of code, 2 lines of code. They were very simple. If you started doing this in a more, again, professional sense, or trying to do something more interesting with this, you could come up with some very interesting stuff. So really, your imagination is the only limit. Happy to take any questions.
Any questions for Adrian? See anyone?
I will take stunned silence. Pooh Bear demands them.
I can hear someone. Oh, there we go.
When you hook a DLL...
I hear whistling and stuff.
Yeah.
Is that a question?
When you've got a DLL, you're loading the DLL. When you compile it in C#, it makes references. When you're hooking a function, those functions are local to the DLL or they're local to the process. It must be the process because you're hooking process level functions in. Is that right?
Yep, that's right. The main reason it all works is the IIS module that we wrote for the IIS related stuff is getting loaded by IIS. So that's being loaded into the instance of W3WP that is actually handling your request. So when someone authenticates to their email account, that authentication request is being handled by that IIS worker that our mod has also been loaded into and been able to hook those functions. So yeah, there's no cross-process stuff going on here.
Hey, buddy. What sort of logs and stuff are generated when you load an IIS module?
When you load it into IIS, as far as I know, nothing. I mean, IIS mods, or modules rather, I shouldn't say mods because it's part of the talk. IIS modules are just a native part of how IIS works. So as far as I know, you wouldn't see much. That being said, they're not completely impossible to see. We saw the list of installed modules halfway through the talk. So forensically, this is not a stealthy attack. Like, you come along and just list the modules, and all of a sudden you've got IIS mods.mods. It's going to look a little sus.
Hello.
Hello.
So I have a two-part question. I've written in here, it says, hooked function from inner hook, what happens? Do you know what my question was? And B, what the answer is?
I do know what your question was. You're talking about me saying that you shouldn't call the log function from within the hook that is hooking the log function. That you shouldn't do that because you cause an infinite loop. Because when you now try to call the log function, Harmony tokes over and says, well, there's a prefix hook for that, and it calls your prefix function again. So you're basically just infinitely calling your own prefix function trying to call the log function. Was that both the questions?
Yes, it was. So if I do that, is that like going to be another nuke?
Yeah, sure, if you want to nuke yourself. I mean, it's a typical recursion thing then, so you'll hit like the stack limit of however many functions deep you can call. It's dependent on the language there, but I think a lot of them it's like 512 or 1024. Like, eventually you'll just get a big-ass exception thrown that'll print out 4 pages worth of log prefix, log prefix, log prefix.
Here comes Jess. There's one up the front here.
No, don't shout. It doesn't work.
It's a good workout being a runner in this theatre.
You mentioned doing these things will kind of prevent 99% of web exploitation,
Yep.
web share or whatnot. Do you have an idea on how much that will break legitimate applications?
Absolutely. That was part of the talk until the code was too small to talk through. Sub-process-based shells, like if you hook process start, it's probably going to be fine for 99% of web servers out there. If you were to hook assembly.load, most normal web servers will be fine. I know things like Exchange do legitimately use assembly.load in some places. A lot of CMSs and plugin-based systems use assembly load as well, so that would break them. But that's assuming that we go full nuclear, like return false, we break that function permanently. The advantage of this approach is we can selectively decide when we return false. So we can build a bit of like a whitelist in saying these functions are allowed to load or these assemblies are allowed to load. Anything outside that list we return false for and we disable that function. Dynamic C# compilation I think will work on like 99% of servers unless you're doing some really dumb shit. But from past experience, people do a lot of really dumb shit on IIS. So test them in your dev environment before you go to prod.
Awesome. I think we'll end it there. Great talk. Another round of applause for Adrian, please.
Thank you.